This is a video from section 4.9 in a Calculus 1 class. The directions say to find the most general antiderivative of the function. And with that, we're going to take a look at problem number 5. Suppose f of x is equal to 4x plus 7. Okay? So we need to think of a function so that when we take its derivative, we get 4x plus 7. Now, something to keep in mind. So I know the derivative of x squared is equal to 2x, correct? But I don't need a 2. I need a 4. So notice that if I take the derivative of 2x squared, isn't that equal to 2 times the derivative of x squared, which is 2x? And that's equal to 4x. That's what I want, right? And notice the derivative of x is 1. So if I take the derivative of 7x, that's equal to 7 times 1, which is equal to 7. And that's also what I want. So the general antiderivative is going to look like the following. Capital F of x is going to equal 2x squared plus 7x. That's an antiderivative, but remember, we want the most general. And so what we need to do is add c to the end. And note here, c is constant. And the derivative of any constant is 0. And so this is the correct answer for problem number 5. Let's take a look at problem number 6. Suppose f of x is equal to x squared minus 3x plus 2. And I want capital F of x. So you need to think backwards, right? Now, let's go through this again. Remember that the derivative of x cubed is 3x squared. But I don't want that 3 there. I want a coefficient of 1. And so I'm going to take 1/3 of x cubed minus. Now, the derivative of x squared is equal to 2x. But I don't want the 2, and so I'm going to take that 3 and divide by 2 and multiply by x squared. The derivative of x is 1, so the derivative of 2x is 2 times 1. And so I'm going to add 2x. And remember, to the end of every general antiderivative, we add c. And that's how we do number 6. Let's take a look at number 7. So if I have f of x equals, and you get 2x cubed minus 2/3 x squared plus 5x. And remember, we're trying to think backwards now, which means we're going to move up a degree. So if I want capital F of x, the 2 goes along for the ride, and I'm going to multiply by x to the 4th. But let's come over here. The derivative of x to the 4th is 4x cubed. I don't want the 4 there, so to counterbalance, I'm going to divide this term by 4. And then I'm going to go minus 2/3 times x cubed, right? We move up a degree. But take a look at this. The derivative of x cubed is 3x squared. And so to counterbalance that 3, I'm going to multiply by 1/3. So you're either dividing by 3 or multiplying by a third. And then I'm going to go plus 5 times x squared. So notice I move up a degree again, but I get to divide by 2 this time, plus c. So therefore, capital F of x is 1/2 x to the 4th minus 2/9 x to the 3rd plus 5/2 x squared plus c. And that's how we do problem 7. Let's take a look at problem 8. Suppose f of x equals, we get 6x to the 5th minus 8x to the 4th minus 9x squared. Now, I want capital F of x. So I get to take x and move it up a degree. And so I'm going to go for x to the 6th, because that's 1 up from 5. And if you look, the derivative of x to the 6th really is 6x to the 5th, right? And so, and I want that 6 there. So the first term is good. Minus 8x to the 5th. But let's check out that x to the 5th. If I take the derivative of x to the 5th, I get 5x to the 4th. But I don't want the 5 there because that's not an original. So I have to divide by 5 to counterbalance. Minus 9x cubed, right? But if we can, the derivative of x cubed is 3x squared, okay? And so to counterbalance that, I'm going to divide by 3. And so if we simplify, and by the way, if we want a general antiderivative, we add c. And then to simplify, we get x to the 6th minus 8/5 x to the 5th minus 3x cubed plus c. And so this is capital F of x. That's number 8. Number 9. Suppose f of x is x times 12x plus 8. And I'm going to rewrite this as 12x squared plus 8x. So I just distribute the x inside. Capital F of x equals. Now, I get 12x cubed, right? But I need to divide that 12 by 3. And then I'm going to add 8x squared, and I get to take that 8 and divide by 2, and then I add c. So if I go to simplify that, I'm going to say the following. Capital F of x equals, now look, 12 divided by 3 is 4. So we get 4x cubed plus 4x squared plus c, right? That's how we do problem number 9. If we take a look at 10, f of x is x minus 5 squared. But if we square that out, we get x squared minus 10x plus 25. So if I want capital F of x, I'm going to get x cubed, right, times a third minus 10 times x squared, right? But I have to divide that 10 by 2 plus 25x, right? Because the derivative of x is 1 plus c. And if I simplify, I get 1/3 x cubed minus 5x squared plus 25x plus c. And that'll conclude this video for section 4.9. And I did problems 5 through 10. Thank you.